Okay, so I finished that homework problem, and now I want to develop a couple more trig IDs. I was looking at your list and it looked pretty sad, so let's add trig IDs with the numbers, I think 24, 25, and 26. If that's not right, you can correct me. I want to time this. So 24, 25, and 26. You can correct me tomorrow. And these go on your page where where it's tabulated. And I was wondering, what is the relationship between the sine of an angle and the sine of a negative angle? If you have some space on the response side, you may write down why this is true as I develop it. If you do not have room, you may skip that part. You just have to have the trig ID that results from this discussion. Well, the sine curve looks like that, going up to 1 and down to -1. And it turns out that if I pick an angle along this x-axis, say theta stops right there. You can pick any angle. I want to compare that to the sine of minus theta. Well, sine of theta is found by going up or down and reaching the graph. In this case, I have to go up, and then you read the value over here. That's the sine of theta. As I kind of darkened it there. Now I look at sine of negative theta. So if this is theta, I'm going to go equal amount in the other direction. There's negative theta. So I'm going to go up or down to reach the graph. If I go up, I'll never reach the graph, so I have to go down and over to read the value on the y-axis. That is the value of sine of negative theta. Notice they are the same in magnitude but different in direction. This one's positive and this one's negative. So I can't say that sine of theta equals sine of negative theta unless I add something to the equation. What could I add to make them truly equal? Right now, one is up and one is down. So can you see if I make one side negative, I can move this one down or this one up. It doesn't matter. As long as I put a negative sign on one side or the other, they will be equal. So, since this one already has a negative sign, I can put it there. Now this is a true trig ID. So add that to your list. If you have room on your response side to discuss this graph, add it. If not, that's okay. Here's the cosine curve. And I was wondering what happens to the cosine of an angle compared to the cosine of a negative angle. So you see from the discussion you saw on this one, let's see if you can come up with the relationship. So think it out for a second. You're going to go say this much is theta. You're going to go up and evaluate that. And then you're going to look at negative theta. So work ahead of me. I'm going slow. Go up again, because if I go down, I'll never reach the graph. So I have to go up and I read the value at the same spot. Do you see on this curve, they are equal. I don't have to change a thing about that statement. And there's your ID number 25. Notice it's because the cosine curve is symmetrical to the y-axis. Same thing on the left of it as the right. And tangent theta, I'm wondering how that relates to tangent of the negative angle. Can you come up with how that works on your lonesome? Alright, here's a sketch. Remember it went through the origin. I'll just take that portion. Theta goes up to here, negative theta, say goes to here. And notice it works just like the sine curve. One is up and one is down. So to make them equal, I have to negate one side or the other. Those are 3 new trig IDs for this lesson. And now you can go back and do number 9 and 10 at the top of the green sheet. And because now that you have that information, These are trig IDs. You can substitute, whenever this comes up in a problem, you can substitute this. Whenever this comes up in a problem, you can substitute this. Whenever this comes up in a problem, you can substitute this. All right. I erase, you can pause if you need it for anything. And I still got a few minutes on this segment. The main part of our lesson, really what I've done so far, was sort of bleeding over from yesterday's lesson. What I'm going to look at today is using trig IDs to simplify expressions. Whenever I say the word simplify, I hear the Holy Spirit telling me to simplify my life. Here I am telling you guys to simplify all the time. How about simplifying in my own life? So, Holy Spirit, your whispers are not unheard. All right. What we're going to look at is I'll give you two expressions, and tomorrow in class we'll do a whole lot. We need to bring out our suitcase. We're not going on a trip, but we're going to carry some things around. Sometimes it's negative to carry a lot of baggage. We're going to be happy about this baggage. So I'll put some things in our suitcase. You remember other times we used a toolbox and we used keys? Well, we got a suitcase on these trig ID simplify problems. Here's what it'll say. It'll say simplify, and it looks like this: sine x times cosine squared x minus sine x. And all you have to do is simplify that. One of the first things in your suitcase is factoring. So factor is the first thing that I notice when I do simplify this. I'm going to pull out what's common to both. When I do that, look what's left. Cosine squared x minus 1. So now I have to use substitution, another thing in my suitcase, because that is one of the Pythagorean IDs. They're one of the rearrangements of the Pythagorean IDs. If you look at it and in your mind switch it around, you'll see that cosine squared minus 1 is the same as sine squared. And then we can finish with sine cubed, because that's the product of these two. This is your answer. How do you know when you're done, when it can't be simplified any further? So there we are. I'm just going to do one more. Write this one down. Pause. I'm probably going a little quick for you to get it down and absorb it at the same time. This simplification looks like this. Sine of t, any old angle, times sine of t plus cosine of t times cosine, I'm sorry, I didn't read that right. Sine of t, erase, plus cotangent t, that's confusing, times cosine t. There, I got it. And the command is simplify. And I'm going to start with my substitution. There's nothing I can factor out of this as it is. But I notice that I have sines and cosines. So what if I rewrite cotangent t as sine or cosine? Well, it happens to be. So we can say write as sine or cosine. That's a valuable tool in itself. So cosine t over sine t is what cotangent is, cosine over sine, times cosine t. Alright, now I've gotten rid of the cotangent. I have all sines and cosines. So this one is sine t plus cosine squared t over sine t. So let's add these, give them the same denominator. So we'll say add algebraically. I don't know how to spell that. You can correct me tomorrow. So in order to give this the same denominator as that, I multiply by sine t over sine t. So my common denominator is sine t, and now the numerator becomes sine squared t plus cosine squared t. Ding, 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 ding. That is our trig substitution. I don't have to turn the video off, we're almost done. Sine squared plus cosine squared is, God's little joke to us, 1. So we end up with 1 over sine t, which is cosecant t. Can't get any more simplified than that. Alright. That's the kind of thing you're going to have to think through tomorrow. Notice that every problem is done differently, and you just have to pull from that suitcase until you get it down and down and down to something that is simplified all the way. Alright, so tomorrow we'll be practicing that, and you can review this video. If there's anything you don't understand, please watch parts of it again and come in strong. So, see you then. Bye.